Okay, so we are going to start with basic principles of organic chemistry. This is the first chapter and very fundamental chapter of organic, which will cover lot of concepts which will be required to explore the organic chemistry in the 11th as well as 12th standard. Okay, so let's start with the name. What do you understand by the word organic? Yes. Or what are organic compounds related with?
Carbon.
Carbon. So the first thought that comes into mind is carbon compounds. But if we go back to the history, organic compounds were actually first derived from living organisms, meaning plants and animals. Through the living organisms, the word organic was given to these set of compounds which were naturally derived. And back then, it was believed that organic compounds could only be derived from natural sources, that is plants and animals. ये कंपाउंड्स को लैब में सिंथेसाइज नहीं कर सकते या आर्टिफिशियली प्रिपेयर नहीं कर सकते हैं. So there was a scientist named Berzelius who thought that these compounds have something special in them, which is why the natural source was possible for these compounds to be discovered. So he proposed a theory called vital force theory. Berzelius ने एक theory दिया that was called vital force theory. He said that there is some vital or unimaginable force which is driving the organic compounds to be existing from the natural sources, and these compounds can't be artificially prepared. So this theory was completely disproved by a scientist named Wöhler, because after a lot of research, Wöhler came up with the synthesis of first organic compound in the laboratory. मतलब artificially prepare करके he actually discovered the first organic compound, and the reaction associated with the first organic compound discovery was the heating of ammonium cyanate. Heating of ammonium cyanate. The formula of ammonium cyanate was NH4CNO. So when Wöhler heated this ammonium cyanate, he was able to recover H2NCONH2 molecular formula compound, which was named as urea, and this was the first organic compound which was discovered, rather artificially prepared in the laboratory. So after the discovery of urea by Wöhler, there were lot of other organic compounds which were consequently discovered. So there was a scientist named Berthelot who was able to discover the organic compound ethanol, and there was a scientist named Kolbe who discovered acetic acid. So acetic acid by Kolbe, methane by Berthelot, and there were many other organic compounds which were then discovered through the artificial process. Now, when I talk about the organic compounds, if if I ask you how many organic compounds are discovered till date, answer is 20 million. There are 20 million organic compounds which are discovered till date, and these are all containing one thing in common, that is carbon. Versus if I talk about inorganic compounds, they are just 5 lakh in number, meaning half a million. Organic compound 20 million है और inorganic compounds मतलब just half a million. Now, organic compounds is just made up of the main element carbon. It means that out of 118 elements in the periodic table, एक कार्बन एटम के कंपाउंड्स 20 मिलियन प्लस है, 20 मिलियन प्लस, एंड बाकी सारे कंपाउंड्स को अगर मिला के देखें तो दे आर जस्ट हाफ अ मिलियन. इट मींस दैट कार्बन के जो कंपाउंड्स है वो 20 मिलियन है और 117 एलिमेंट्स रिमेनिंग उनके 0.5 million compounds ही है. So of course there is some special thing about carbon as an atom which is responsible for such huge number of organic compounds. So can you tell me what are the special properties of carbon atom?
Tetravalency.
Correct. Carbon
Catenation.
can form tetravalent compounds. So tetravalency is one thing. Yes. The other is catenation. What do you understand by catenation?
Like it's a property for it to exhibit long chains and it can like bond to itself and other atoms.
Correct. It's the property of self-linking. Matlab, carbon atom can link to itself or it can also link to other heteroatoms like oxygen, nitrogen, phosphorus, halogen. And it is able to form long chains. When I talk about long chains, it can be a straight chain, a branch chain, or even the cyclic chain. So such huge number of chains can be formed through the self-linking property or the linking with other heteroatoms. That property is called as catenation. What else?
Isomerism.
Correct. Isomerism. So isomerism is a property of compounds having the same molecular formula but different
Structural
Structural
formula.
formula.
structural formula. So एक ही molecular formula के through carbon can have different structures possible. And that isomerism is also one of the very important factor which is responsible for existence of such huge number of organic compounds. So to sum up, organic compounds का special, carbon का जो speciality है, that is the tetravalency, catenation and the isomerism property. Now, let's explore the tetravalency of the carbon atom. Now, if I talk about the carbon atoms with respect to hydrocarbons, what type of bonds carbon can form with itself? When you talk about self-linking, कौन-कौन से type के bonds carbon खुद से बना सकता है?
Covalent.
Covalent bonds, and the carbon could be joined by a single bond,
Double
Double
or
and triple.
triple.
Double and triple.
double and triple bond. Correct? This is something you all know that a single bond between the carbon represents the alkane family. Double bond is
Alkene.
alkene and triple bond is.
Alkyne.
Alkyne.
Now, some of the things which you should be knowing after the discussion of the tetravalency is point number one. When you talk about multiple bonds in organic compounds, meaning double or triple, then this multiple bond is always a combination of one strong bond, and other weak bonds. One strong bond and other weak bonds. Okay, the strong bond from now onwards is called as a sigma bond, which is indicated by the symbol of sigma, and the weak bonds are indicated by pi, and the symbol is simply the mathematical pi. They are called pi bonds indicated by pi. So multiple bonds is a combination of one strong and other weak bonds. And the single bonds are always the strong bonds. A single bond is always a strong bond, meaning they are always what?
Alkenes.
No. They are always what type of bonds? Strong bond किसको बोलते हैं?
Single.
हाँ, but we have given a name.
Sigma.
Sigma. Correct? So now, with this discussion, tell me, a single bond between the carbon would always represent a
Sigma bond.
sigma bond. A double will be a combination of
Sigma bond and pi bond.
one sigma and one pi.
One,
A triple will be combination of
One
sigma,
sigma,
two
two
pi.
pi.
one sigma and two pi. Perfect. So this is the new information which you should remember from now. that a single bond between the carbon, a covalent bond which is a single bond, is a sigma bond. Double is sigma plus pi, triple is sigma plus 2 pi. Understood?
Yes, sir.
Understood. Yes, sir. Then, next, there is one important property which will be discussed later in very much detail. This property is called hybridization. This property will overall lead to the conclusion about the bond parameters. Now, when I say bond parameters, matlab, the first comparison, what we will be doing over here is bond length. So, naam se, bond length means the length of a bond. Now, tell me, a covalent bond is formed by
Single bond.
a covalent bond is formed by, it's a single bond, but it's formed by
Sharing of electrons.
super. So if I have two atoms A and B, A के पास एक इलेक्ट्रॉन है, B के पास एक इलेक्ट्रॉन है, आपस में if they share, they will form a covalent
Covalent.
bond.
And
For an atom, the central part of the atom is called
nucleus.
Nucleus.
nucleus, and it's surrounded by the shells containing the electrons. So let's say this is the outermost shell of A. Similarly, this represents the nucleus of B, and the outer shell of B is this. So now, when they share the electrons, this is how they would be forming a covalent bond. So the length between A and B is measured as the distance between the center of nuclei of the combining atoms. Once again, bond length is defined as distance between the center of nuclei of the combining atoms. So this length is called as the bond length. Understood?
Yes, sir.
Okay.
So, sir,
Huh.
sir, hybridization is bond length.
No. I'll come back to hybridization. I told that hybridization we will be using to discuss about some bond parameters. Out of which the first bond parameter which I said is called bond length. वो मैंने explain किया. समझा?
Yes, sir.
The second bond parameter is bond energy. Bond energy. So नाम से it is the energy required to
Break a
break the
bond.
bond. Energy required to break the bond. Now, if I consider this bond length to be large, then the distance between the nucleus and electron will be large or small. अगर bond length बड़ा है, तो distance between the nucleus and the
Large.
Large.
electron would be large.
Large.
जितना nucleus electron का distance दूर रहेगा, उतना the attractive force between the plus and the negative electrons would be
Less.
less. So the energy required to break the bond would be
Less.
less. Meaning, if the bond length is large, the bond energy is
Low.
low. So what is the relation between length and energy?
Inverse.
Inverse. Do you all agree with this?
Yes, sir.
Yes, sir.
So bond length is inverse to the bond energy, a very important relation. Larger the bond length, weaker is the bond, lesser is the energy required to break the bond. Samjha?
Yes, sir.
Next, there is one more bond parameter which we will be talking about, that is electronegativity. So in redox also we have discussed this in detail. What do you understand by electronegativity?
The ability of an element to attract the shared pair of electrons.
Superb. The ability of an element or an atom to attract the shared electron pairs towards itself. So if I talk about A and B, and if say I say B ka electronegativity is more than A, It means that B ka electron attracting power is more than A.
Yes, sir.
Yes, sir.
ठीक है? तो in simple language, electronegativity, I call it as electron खींचने का power or simply electron withdrawing power.
Hmm.
Electron
Withdrawing
Withdrawing.
power.
withdrawing power. Okay? Now, all these bond parameters we will explore by using the concept of hybridization. Okay? So, hybridization will be used to decide the bond parameters. And in simple words, hybridization is a combination of orbitals. A combination of
Orbital.
orbitals. Now, heard about orbitals? अच्छा, ऑर्बिट के बारे में सुना है?
हाँ.
Yes, sir.
तो आप सबको पता है that the atom consists of a central part called
Nucleus.
nucleus, and it is surrounded by shell or orbit which
Orbits.
contains
Electrons.
Electrons.
negatively charged electrons. इतना सबको पता है?
Hmm.
Yes,
Yes.
sir.
Yeah.
So this is a partial information. You all know that electrons are present in a shell, also called as the orbit. But actually, the orbit or the shell is further divided into subshells. Orbit or the shell is further divided into subshells. Subshells are further having orbitals, and the orbital finally contain the electrons. So there is modification to the information you know. Electrons do not reside in a shell, but they reside in the
Orbitals.
orbitals. Do you all understand?
Yes, sir.
It's like saying that you reside in a building, but actually that is partially correct. You reside in one of the flat of a building. समझ में आया?
Yes, sir.
ठीक है, सो बिल्डिंग के अंदर फ्लोर्स होता है, हर फ्लोर पे फ्लैट्स होते हैं, फ्लैट के अंदर आप रहते हो, बराबर? तो 10 तक आपने बोला कि आई रिसाइड इन अ बिल्डिंग, बट नाउ यू शुड से आई रिसाइड इन वन ऑफ द फ्लैट ऑफ द XYZ बिल्डिंग. सिमिलर लाइंस पे इलेक्ट्रॉन्स रिसाइड इन वन ऑफ द
Orbitals.
ऑर्बिटल ऑफ द शेल. समझा?
Yes, sir.
Yes,
Yes,
sir.
sir.
ठीक है? Now, these orbitals are nothing but the blocks of the periodic table. Do you know that periodic table is divided into some blocks?
S block, P
Yes.
block.
S
Yes,
block.
sir.
S block, P
S
block,
block,
D
B
block
block,
and
F,
F block.
F.
तो ये नाम जो SPDF आता है, that is the name of the orbitals. वो फ्लैट के नाम है हर फ्लोर पे. S orbital, P orbital, D orbital, F orbital. ठीक है? अब
Yes,
आगे
sir.
एटॉमिक स्ट्रक्चर का जो चैप्टर है, यू विल अंडरस्टैंड द detailing about what I have just discussed. But as of now, I require the hybridization for comparing the bond parameters. So that's why I have just talked about hybridization as a combination of orbitals. Okay.
Yes, sir.
Now here
Yes.
we are focusing on which element?
Carbon.
Carbon.
Carbon. What is the atomic number of carbon?
6,
6. What's the configuration?
2, 4.
2, 4. Now with the 6 electrons distributed as 2 in the first shell and 4 in the second shell, carbon is associated with only S and P orbital. Yani carbon में D and F doesn't exist. Why? You'll get the reason in the next chapter. As of now, for you to understand this further part, remember that carbon with the atomic number 6 is concerned with only बोलो
Or orbitals.
Which
S and
orbitals?
P orbit.
SNP.
S and P. So finally, hybridization gives you the combination of orbital ka information. And which orbitals I am going to consider?
SNP.
SNP.
So there are three combinations which exist for the organic compounds. The first is sp3, combination of S and 3p. Double bond is a combination of S and 2p. And triple bond is combination of S and 1p.
Three.
Hence, the three hybridization which you will be always remembering for organic is sp3, sp2
SP2.
SP1.
and
And
sp1 या
FP1.
just sp बोलो आता है समझ में
Yes, sir.
Yes, sir.
ठीक है now when we talk about s and p orbital I'll just talk about one simple comparison between s orbital versus the p orbital ठीक है two things you should always remember about them point number 1 s orbital is smaller in size s और p में छोटा कौन
S.
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 ठीक है और दूसरा पॉइंट s is closer to the nucleus nucleus से closer कौन
S.
s once again I repeat the information which you should be remembering as of now for s versus p is s and p में size wise कौन सा बड़ा है
P.
P.
p यानी s ऑर्बिटल छोटा हुआ एंड
Yes.
न्यूक्लियस से क्लोजनेस किसका है
S.
S.
s का Now, having understood this, let's understand the main conclusion why we are discussing this in detail. Okay, so if I talk about the bond length, so we know the bond length parameter I explained you.
Yes, sir.
Yes.
Okay, between S and P, since the S orbital is small and the P orbital is large, then the bond length will be decided by the proportion of P present in the combination of S and P. मतलब given the combination of S and P, if the P का proportion is higher in one of the organic compound, then its bond length is going to be
Higher.
higher. See, size wise अगर P larger orbital है तो P का जितना proportion ज्यादा उतना bond length भी ज्यादा आता है समझ में ये
Yes, sir.
Yes, sir.
So can I simply say bond length is directly proportional to percent of P?
Yes, sir.
Yes.
Okay, now I will just first talk about the percent of P. sp3 में there is one S and 3p.
75.
So P का percent would be 3 upon 4 into 100. Do you understand the math over here?
Yes, sir.
There is one S and 3p. तो total orbitals 4 हो गए. तो P का
Yes, sir.
percentage कितना हुआ? 3 upon total
75.
4 into 100. Do you all agree?
Yes, sir.
75 is the answer. Next कितना होगा?
3. 66.66.
66.67.
Great. 2 upon 3 into 100. 66.66. And
Yes, sir.
50%.
SP में just 50%. Half हो जाएगा, right?
50%.
With the percentage of P, can you tell me which is going to have the highest bond length?
SP3.
SP3.
मतलब single bond. यानी carbon to carbon single bond has the highest length of 154 picometer. How much is pico?
10 raised to minus 12.
10 raised to minus 12. Then the bond length is going to decrease from the single to triple bond. So the next one is 133 picometer. Next is 120. Value आपको याद रखना है, but comparison जो मैंने दिया, that higher the percent P, more is the bond length. That is important to understand.
Yes,
Got
sir.
it?
Yes.
Yes, sir.
अब if I have bond length with me and if I ask you bond energy का relation, किसका bond energy सबसे ज्यादा होगा?
Sir, SP.
sp. So triple bond, can I say, will have highest bond energy?
Yes, sir.
Yes, sir.
And isn't that logical? Triple bond is 1 sigma and 2 pi. यानी एक सिग्मा और 2 पाई को तोड़ने के लिए, ब्रेक करने के लिए जो एनर्जी लगेगी वो डबल और सिंगल से
ज्यादा होगा.
ज्यादा लगेगा. सिंपल लॉजिक है कि नहीं?
Yes, sir.
ट्रिपल is 3 bonds का breakdown will require obviously higher energy than double या single. Hence proved that triple will have the highest bond energy. Got my
Yes,
point?
Yes, sir.
Okay. So we discussed about bond length, we discussed about bond energy. अब तीसरा पैरामीटर जो डिस्कस करना है वो है इलेक्ट्रोनेगेटिविटी. So as we said, electronegativity is electron attracting power.
Yes, sir.
Yes,
So
sir.
these electrons will be attracted more if it is closer to the nucleus.
Yes, sir.
Yes, sir.
So if it is closer to the nucleus, then more will be the electronegativity. So for the closeness, which orbital percent should be more?
Yes.
ये देखो यहीं पे है ना relation.
Yes, sir.
So electronegativity is directly proportional to
Bond
percentage
energy.
of
S.
Yes.
S. अब मैथमेटिकली परसेंट ऑफ S निकालने के लिए क्या करेंगे?
Subtract 100 में से.
100 में से सब्ट्रैक्ट कर लो. बस थोड़ी करना है. 75 का यहाँ पर S परसेंट हो जाएगा 25.
25.
33.33.
33.
50.
कंक्लूजन, मोर द S, मोर इज इलेक्ट्रोनेगेटिविटी. किसका सबसे ज्यादा?
SP.
sp, ट्रिपल बॉन्ड का.
Triple bond, sir.
ठीक है. सो वैल्यूज के साथ अभी याद रखना है 2.5 is the electronegativity of single bonded carbon, increasing to 2.8 and further increasing to 3.3. So this completes a very important table describing the bonds between the carbon atoms with their hybridization and the information about the bond length, bond energy, and electronegativity. Have I made it clear up till here?
Yes, sir.
Yes.
Yes, sir.
कोई डाउट यहाँ तक?
No, sir.
No, sir.
Okay. This is all given in the synopsis also, and some important extra points which you should be noting. I'll send you the PDF of the slides so you can make your notes, the addition in the booklet itself.
Sir,
Hmm.
is there logic between the hybridization naming SP3, SP2, SP?
Of course. But this logic, as I said, you will understand once you complete the orbitals part and move to the chemical bonding. तो
Okay, sir.
तब तक वो आपको समझना नहीं है because आएगा ही नहीं समझ में.
Okay.
Okay. As of now, the conclusion which you should know from this particular table is a single bond carbon is sp3 having a percent of p75, due to which its bond length is higher, bond energy is lower, and the electronegativity is also lower. That's it. अगर इतना समझ में आ गया, it's sufficient.
Okay, sir.
Okay?
Okay, sir. Okay, sir.
Great. Now we'll move on to the discussion of some questions which is given in the synopsis on page number 3. If you have the synopsis with you, you can just refer that. So that is problem 8.1, which asks how many sigma and pi bonds are present in each of the following molecules. So the first compound they have given is HC, triple bond C, CH, double bond CH, and CH3.
10 sigma 3 pi.
Okay, and how do you find that?
So because pi bond 2 we can find easily because we have the triple bond, double bond. In double bond there's one pi bond and in triple bond there are two. So 1 plus 2 is 3. And
Perfect.
when you draw the structure, you can see the carbon to with hydrogen
Hmm,
plus the double bond and triple bond ka single sigma, and then when you add it up you get 10.
perfect. So basically, from the structure, you have to identify the sigma and pi bonds through the detailed structural formula. Meaning, here each of the atoms should be joined by a single bond. So when I draw the structural detail, I should draw H single bond C, triple bond C, single bond C, single bond H, double bond C, single bond H, single bond C, H, H, H. Correct?
Yes, sir.
Now, as we discussed in the previous slide, all the single bonds are always
Sigma.
Sigma.
sigma. A triple is combination of
Sigma
1
and 2
sigma
pi.
2 pi.
1 sigma, 2 pi. Singles are always sigma bonds and double will be a combination of
Sigma
1
and pi.
sigma 1 pi.
1 sigma, 1 pi. Now इसमें detailed information की बात करें तो first of all, how many carbon to carbon sigma bonds do you see?
4.
4.
So between carbon, this is 1 sigma, 2 sigma, 3 sigma, 4 sigma. So carbon carbon का sigma है 4. Sigma between carbon to hydrogen are.
6.
6.
6.
In fact, whatever number of hydrogens are there always be the sigma bonds, right? Because hydrogen तो monovalent होता है. मतलब ये 6 हो गया. पाई तो देख के ही समझ में आ गया होगा. ये 2 ट्रिपल में and 1 डबल में. So pi is 3. So therefore, sigma total अगर पूछा तो कितना हुआ?
Sigma total. 6.
6 and
6
4,
plus 4, 10.
10 हो गया. And pi
Yes.
total तो 3 है ही.
3.
Therefore, total bonds पूछ लिया तो
10.
हाँ total 10 and 3 ना.
10, 30.
13.
30.
सिंपल.
Okay.
टोटल बॉन्ड्स कितना हो जाएगा? 13. मतलब मैंने डिस्ट्रीब्यूटेड इंफॉर्मेशन बताया. पहले सिग्मा बिटवीन कार्बन हाइड्रोजन एंड पाई. फिर टोटल सिग्मा एंड टोटल पाई एंड देन टोटल नंबर ऑफ बॉन्ड्स इन द मॉलिक्यूल व्हिच इज इक्वल टू 13. गॉट इट?
Yes,
Yes,
sir.
sir.
ओके, तो अब एक और एग्जांपल है. लेट्स ट्राई दैट. वी हैव CH2 डबल बॉन्ड C डबल बॉन्ड CH3. पाई तो डायरेक्टली दिख रहा है. कितना होगा?
2.
2.
2.
सिग्मा के लिए जस्ट हाइड्रोजन्स के साथ बॉन्ड्स को ओपन अप कर दो. तो
9.
CH2 डबल बॉन्ड C पे H. Then there is of course a single bond between carbon and then single bond between carbon and hydrogen. तो इससे आपके मिस्टेक्स होने के चांसेस जीरो हो जाएंगे, राइट?
Yes, sir.
Yes.
सिग्मा
Yes, sir.
सिग्मा सिग्मा एंड पाई, सिग्मा एंड पाई,
Yeah.
then sigma sigma,
Sigma.
all the single bonds are sigma. Again sigma carbon carbon कितना?
3.
3.
3. Sigma carbon hydrogen
6.
6.
6. Pi,
2.
2.
therefore sigma total
9.
9.
9 and pi is
2.
2.
therefore total bonds
11.
11.
11. समझा?
Yes, sir.
Yes, sir.
Okay. Now along with this, the question could be about hybridization of the carbon in the molecule given. Now to check the hybridization, I'll give you one simple trick. If the carbon atom is joined only by sigma bonds, then its hybridization is
sp3.
sp3.
मतलब only sigma, है ना? If the carbon is having one of the pi bond, एक pi bond,
sp2.
then it will be sp2.
sp2,
If the carbon atom is joined by
2 pi
2
2
pi,
pi, then it is sp.
1.
So can I say no pi bonds will be sp3, 1 pi will be sp2, 2 pi will be sp. Correct?
yes, sir.
Yes, sir.
So let me ask the question here. This carbon from left to right is what hybridization?
Left to
This
sp3.
carbon,
sp1. sp1.
ये वाला दिख रहा है क्या?
Yes, sir.
क्या होगा?
sp1.
sp,
sp. 1 बोलने की जरूरत नहीं है, it's just sp. This carbon, second one,
sp3.
no.
sp.
sp2,
देखो कंफ्यूजन ना
sp,
हो तो मैंने सिंपल बना के रखा है. ये कार्बन पे फोकस कर रहे हैं हम. एवरीवन,
Yes, sir.
this carbon is connected with 2 sigma and 2 pi. Can you see this carbon in the focus?
Yes.
yes, sir.
ठीक है. तो ये जो कार्बन एटम की हम बात कर रहे हैं उसमें नंबर ऑफ पाई बॉन्ड्स खाली चेक करो कितना दिख रहा है.
2 pi
2,
bond.
मतलब कार्बन के टेट्रावैलेंसी में इफ देयर इज नो पाई इट्स sp3, 1 पाई sp2, 2 पाई sp. खत्म हो गई बात.
yes,
Yes, sir.
sir.
Yes.
This carbon is now confirmed to be
sp,
sp. आगे.
sp2,
This carbon is having 1 pi to sp2. Next.
sp3.
sp2,
sp2.
Again 1 pi
sp2,
sp2. Last carbon if you observe चारों bonds
sp3,
सिग्मा है मतलब नो पाई sp3. एरर होने के चांस ही नहीं है. राइट.
yes,
Yes.
sir.
अब सेम यहाँ पर भी अप्लाई करते हैं. व्हाट इज फर्स्ट कार्बन?
sp2.
यू विल अग्री.
Yes.
Yes, sir.
मिडिल कार्बन, सेकंड वन, सॉरी,
sp.
sp.
sp,
sp. Why? Because this carbon is
there are
connected
2,
with 2 pi.
2
pi.
pi.
सबसे important example, huh? If
yes,
the
sir.
carbon is having 2 pi bonds, meaning if there is a carbon having 2 double bonds on the same carbon, hybridization will be sp.
sp.
Very
sp,
important, very important, very, very important. And this carbon,
sp2.
sp2,
sp2. And the last carbon,
sp.
sp3,
sp3. Understood.
Yes, sir.
yes,
Yes.
sir.
Yeah. So simple in this question, we explored the concept which I just discussed in this table about the type of the bond sigma and pi, and also the type of the hybridization, which can be sp3, sp2, sp, with a simple rule and trick to find the hybridization by just looking at the number of
Pi
Pi
bond.
bond.
super number of pi bonds. Trick clear?
Yes,
Yes,
sir.
sir.
Okay. Now moving to the problem number 8.2, page number 3. So problem 8.2 says what is the type of hybridization of each carbon in the following compounds? Now this should be easy for you. First one, CH3Cl,
sp3.
sp3.
sp3,
because carbon would be joined with all sigma bonds, so it will be sp3. Understood?
Yes, sir.
yes, sir.
B compound, CH3 twice CO.
sp3, sp2, sp3.
Ha. Now to say that, it's better that you write the structure. This is actually the condensed form. Means the two methyls are clubbed together and it indicates that it's attached to the same CO carbon. So can I say it's CO at the center attached to CH3 and CH3?
Yes,
Yes
sir.
or no? Now, if I talk about this oxygen atom, what will be bonding between carbon and oxygen?
Double
Double
bond.
bond.
Why?
Double.
Because
Oxygen
oxygen
has
has
double
two
valency.
valency.
Double nahi, divalency.
Divalency.
Oxygen has divalency and carbon has tetravalency. तो कार्बन ने अपने दो बॉन्ड सेटिस्फाई कर लिए हैं, ऑक्सीजन का दोनों बॉन्ड बाकी है, तो आपस में डबल बॉन्ड हो जाएगा. दिस इज द स्ट्रक्चर. अंडरस्टूड?
Yes,
Yes.
sir.
Once you know the structure properly, you are bound to get the correct hybridization. So the first is all sigma bonds, matlab
sp3.
sp3,
middle carbon,
sp2,
1 pi. ऐसा बोलने का 1 pi therefore sp2. So it's bitter and clearly understood. लास्ट में क्या बोलोगे?
No pi.
sp3
sp3.
sigma,
No pi.
no pi.
ऑल सिग्मा या नो पाई? हो गया बी. समझा?
Yes, sir.
Yes, sir.
Yes, sir.
ओके. नेक्स्ट इज CH3CN.
sp3
sp3
sp.
sp.
sp3 sp.
Because if you say CH3, then CN matlab the carbon would be joined by single bond, but nitrogen is what
Trivalent.
valency? ट्राइवैलेंसी. तो कार्बन की
Trivalent.
3 बॉन्ड्स बाकी है, नाइट्रोजन भी ट्राइवैलेंसी है, आपस में they will share to form a triple bond.
Triple bond.
So once you are able to draw the structural formula indicating all the bonds, the hybridization is bound to be correct. ये all sigma sp3 हो गया, ये 2 pi sp हो गया. We are just focusing on carbon, right?
Yes, sir.
Yes, sir.
कुछ डाउट्स रहेगा तो पूछो. हाँ? Next is a very important example. HCONH2.
sp2.
And to get that, you should know the structure. So how did you draw the structure, Paridhi?
So C with single bond H, double bond O, then single bond N, and then single bond of 2H.
Superb.
Okay.
Carbon is tetravalent. हाइड्रोजन के साथ तो सिंगल बॉन्ड होगा, ऑक्सीजन के साथ डबल बॉन्ड, और नाइट्रोजन के साथ वापस सिंगल बॉन्ड, बिकॉज 3 बॉन्ड तो सेटिस्फाई कर चुका है, बचा एक ही बॉन्ड ना.
Yes,
Yes.
sir.
In short, you should just remember carbon is tetravalent, hydrogen can form only one bond, yani monovalent, oxygen can form
2 bonds.
Dive.
Divalent.
divalent, and nitrogen can form 3 bonds,
Trivalent.
मतलब trivalent. बस सबका
Dive.
वैलेंसी सेटिस्फाई करना है, और अगर वो आपको समझ में आ जाता है, you can clearly say this carbon is having one pi bond now, and that's why it is sp2 without
sp2.
any doubt. Correct?
So we
Yes,
don't
sir.
have any sp for n.
No, no, no.
Okay.
Nitrogen pe we are not focusing now, because here we are just talking about carbon compounds. मतलब कार्बन पे ही अपना फोकस होना है.
Yes, sir.
ठीक है. Next, we have CH3, CH, double bond CH and CN. Can you tell me the structural formula?
P with 3 hydrogen, single bond,
Yes.
and then single bond another carbon,
Hmm.
one
Double bond.
hydrogen and double bond carbon,
Hmm.
single bond hydrogen, single bond carbon, and triple bond
Triple bond
nitrogen.
nitrogen.
Superb. So if you are able to understand this, in fact, C में we have already seen the CN, cyanide functional group, which is having C triple bond N. देखो यहाँ पर भी दिख रहा है क्या?
Yes, sir.
Yes, sir.
उसके
Yes.
basis पे now, first carbon hybridization is
sp3.
sp3,
sp3. Second,
sp2.
sp2,
sp2.
1 pi bond sp2, ऐसा बोलो. Third,
sp2. 1 pi
sp2,
One
bond.
pi
pi
bond
bond,
sp2.
हाँ. And
2
last,
pi
no
bond
pi bond
sp.
No
sp.
pi sp.
हाँ ना ना, no pi नहीं, 2 pi.
2 pi.
नो पाई नहीं, 2 पाई, 2 पाई sp होता है, नो पाई sp3 होता है. Got it?
Yes, sir.
Clear? Any doubt up till here?
No, sir.
Again, the next question from the NCRT, problem 8.3 is write the state of hybridization of carbon in the following compounds and shape of each of the molecules. Forget about shape, पहले hybridization कर लेते हैं. First is formaldehyde H2C double bond O. What's the hybridization? Say 1
sp2.
pi sp2. ऐसा ही बोलना सीखो. You should
Yes, sir.
always tell the answer with justification and it will make sense. क्या बोलोगे?
1 pi
1
sp2.
pi
1 pi
sp2.
sp2.
1 pi sp2. Then
No pi
we,
sp3.
yes, methyl fluoride is CH3 single bond F ले सकते हैं. So no pi या all sigma sp3 हुआ. And C में hydrocyanuric
2,
acid
2 pi
2
sp.
pi sp.
2 pi sp. Got it?
Yes,
Yes,
sir.
sir.
Okay. Now hybridization also gives you the information about shape of the molecule. All these compounds, do they exist in 2 dimension or 3 dimension?
3 dimension.
3
3.
dimension. तो हम जो बना रहे हैं वो तो 2 dimension में बना रहे हैं. But all these
Yes.
molecules are in reality existing in the 3 dimensional region. So these shapes ka information is also given by the hybridization only. तो देखो hybridization कितना important है. It gives you info about bond length. और क्या क्या पढ़ा हमने?
Bond energy.
Bond energy
Bond
and
energy,
electronegativity.
इलेक्ट्रोनेगेटिविटी. और अब चौथा इंफॉर्मेशन ऐड होने जा रहा है. क्या?
Shape.
Shape.
शेप.
Shape of molecule.
सबसे पहले जो sp3 होता है, it has 4 sigma bonds due to which it is arranged in the form of a pyramidal shape called tetrahedral. Tetrahedral.
Head.
मतलब there will be a carbon atom which will have 4 sigma bonds arranged in the pyramidal form called tetrahedral. ठीक है, ये आगे और एक्सप्लोर करेंगे. बट sp3 टेट्राहेड्रल याद रखो. ठीक है. sp2 में there are 3 sigma and 1 pi, right?
Yes.
sp2 में 1 pi है, मतलब बाकी सब तो क्या है?
Sigma.
सिग्मा. तो उसमें जो कार्बन एटम रहता है ना, उसके 3 bonds आर अरेन्ज्ड इन द फॉर्म ऑफ अ फैन लाइक स्ट्रक्चर. जैसा घर पे पंखा होता है ना, वैसा. ये देखो, ये बीच का मोटर है और ये 3 ब्लेड्स है. तो कार्बन भी अपने 3 bonds कुछ इसी तरह अरेंज करता है. और इस शेप को बिकॉज ऑफ दैट हम बोलते हैं ट्राइंगुलर, सॉरी नॉट ट्राइंगुलर, ट्राइगोनल, ट्राइगोनल प्लेनार. Trigonal because there are 3 sigma bonds. Planar because all the blades of the fan are in the same plane. Flat होता है ना, same plane में होता है, right?
Yes, sir. Yes, sir.
तो आज के बाद कभी पंखा देखो तो आप याद रखना ट्राइगोनल प्लेनार. समझा?
Yes, sir.
Yes,
Yes,
sir.
sir.
और sp के केस में there will be 2 sigma bonds and 2 pi bonds, right?
Yes, sir.
2 sigma होते हैं, 2 pi होते हैं. तो यहां पर the 2 sigma bonds would be, sorry, the 2 sigma bonds of the carbon, I think, the 2 sigma bonds of the carbon atom would be arranged in a same line like this. So that is why we name this shape to be linear, because it's arranged in the same
Plane.
line. पंखा एक प्लेन में है और 3 बॉन्ड्स हैं, इसलिए
Yes, sir.
ट्राइगोनल प्लेनार। मेक सेंस?
Yes, sir.
और 2 बॉन्ड्स जो होता है वो एक ही लाइन में होता है, तो उसको बोलना है लीनियर। और जब 4 बॉन्ड्स होंगे तो एक पिरामिडल फॉर्म में अरेंज होता है, जिसको हम बोलते हैं टेट्राहेड्रल। अंडरस्टूड?
Yes,
Yes,
sir.
sir.
So as of now, just remember, when you think of sp3, a single bond or sigma bonds, the shape of that molecule is a tetrahedral. When you think of sp2, think of a fan and call it as trigonal
Planar.
planar. And when you think of sp, you think about bonds in the same line, hence called as
Linear.
linear. ठीक है?
Yes, sir.
Yes.
So this completes the first part of the chapter, wherein we explored about this term called
Hybridization.
hybridization. Is the detailing clear up till this?
Yes, sir.
Yes, sir.
Okay. Now, in the next part, we are going to discuss about structural representation of organic compounds. Meaning, there are different ways in which we can represent an organic compound. So I'll take the simple example of the compounds with 2 carbon having single bond, that is ethane, or 2 carbons joined by a double bond called ethene, and 2 carbons joined by a triple bond called
Ethyne.
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 So ethane is represented by what molecular formula?
C2H6.
C2H6.
CnH2n plus 2 is the general formula, so it gives you the formula C2H6. Ethene
C2H4.
C2H4.
and ethyne.
C2H6.
C2H2.
And if I want to draw the structure through the name ethane, it says that the 2 carbon atoms are joined by a
Single bond.
single bond, and all the hydrogens, of course, has to be joined by a
Single
Single
bond.
bond.
Single
single
bond.
bond. So since there are all single bonds, meaning sigma bonds, the compound is said to be saturated. बोलते हैं कि नहीं, अल्केन्स आर सैचुरेटेड
Yes, sir.
हाइड्रोकार्बन।
Yes.
Yes, sir.
Yes, sir.
ठीक है, बट जैसे ही मल्टीपल बॉन्ड आ जाता है तो these two compounds are classified as
Unsaturated.
Unsaturated.
unsaturated. Structurally, ethene में the 2 carbon would be joined by a,
Double
Double
bond.
bond.
so each carbon will be bonded to how many hydrogen?
4.
2.
2.
Each carbon will be bonded to how many hydrogen?
2.
2,
2.
na?
Yes, sir.
Ethine में the carbon would be joined by a,
Triple bond.
Triple bond. And
each
one
carbon will be
hydrogen.
joined to only
One
One
hydrogen.
hydrogen.
one hydrogen. So through the 3 structures, can you observe from ethane to ethyne, the number of hydrogen are
Decreasing.
Decrease.
decreasing. So unsaturation, in other words, is nothing but decrease in.
Hydrogen atom.
Hydrogen atom.
तो आज के बाद अनसेचुरेशन का एक नया नजरिया मिल गया। अनसेचुरेशन इज डिक्रीज इन नंबर ऑफ
Hydrogen atoms.
hydrogen atoms. Other observation. From C2H4 to C2H6, how many hydrogen are decreased?
2.
2.
2. And from C2H4 to C2H2,
2.
2.
further 2. What's happening between the carbon? With the decrease in hydrogen, what's happening between the
Bonds
carbon?
are increasing.
Multiple bonds are increasing. Rather, to be more specific, which bond is increasing?
5 bond.
5 bond.
Pi bond.
pi bond.
मतलब unsaturation is actually nothing but the presence of
Pi
Pi.
bond.
pi bond. And for every 2 hydrogen ka decrease, there is how many pi bond introduced?
One.
1.
1.
Can I say decrease in 2 hydrogen is equal to increase in
One pi bond.
1 pi.
1 pi bond.
1 pi bond? Very, very important concept. And it's pure observation, nothing to be mugged up. 2 hydrogen ka decrease represents increase of 1 pi bond. You can clearly see there was a sigma bond at the start. 2 hydrogen decrease हुआ तो 1 pi आया और 2 hydrogen तो total 2 pi आया. हाँ कि नहीं?
Yes, sir.
Yes.
मतलब हाइड्रोजन तो डिक्रीज हुआ ही, उसके साथ साथ पाई बॉन्ड्स का इंक्रीज हुआ. 2 हाइड्रोजन का डिक्रीज इज 1 पाई बॉन्ड का इंक्रीज.
Yes, sir.
राइट?
Yes, sir.
Right.
Yes, sir.
Okay. Now, instead of writing all the hydrogens joined by sigma bond, I can just write all the hydrogen connected to the same carbon together as CH3. Can I write them together? Because they are all on the same carbon, na?
Yes, sir.
Yes, sir.
So I can represent ethane also as CH3, single bond, CH3. चलेगा?
Yes, sir.
Next में क्या लिखे?
CH2 double bond
CH2
CH2.
double bond CH2.
CH2 double bond CH2 and then
CH triple
CH
bond
triple bond
CH.
CH.
correct?
Yes, sir.
Yes, sir.
So now the first thing what I drew was called as the detailed structural formula. I'm calling it shortly as SF, structural formula. When I write the similar atoms together on the carbon, that I call it as CSF, condensed structural formula. Everyone, what is the first way to represent?
Structural formula.
Detailed structural formula.
Structural formula. Then you condense it and call it as,
Condensed
Yes, sir.
structural
Condensed
formula.
structural formula.
and this what we write C2H6 together is called
Molecular formula.
Molecular formula.
molecular formula. पता है?
Yes, sir.
ठीक है? But how many ways of writing the organic compound you have understood?
3.
3.
Structural, condensed structural,
Condensed
and molecular
molecular
formula. समझा?
Yes, sir.
Yes, sir.
ठीक है? अब इन्हीं 3 formulas को वापस explore करते हैं through an example of N-octane. What do you understand by octane?
8 carbon and
8 carbons.
by a single
8
bond.
carbon. So can you tell me the molecular formula of this compound?
C8H18.
8H18.
C8H will be
18.
18 because 2n plus 2. तो एक formula clear हुआ?
Yes.
Yes, sir.
Next, what do you understand by this letter N?
Isomers.
N stands for normal chain. And normal chain का मतलब होता है straight chain. N represents a normal chain, which is also called a straight chain. So now, how would you read N-octane? अब detail में क्या बोलेंगे?
Normal chain of octane.
Correct. A normal octane meaning it's a straight chain of
Octane.
Octane.
8 carbon.
8 carbons joined by
18
18
hydrogen.
नहीं, joined by carbons joined by
अच्छा, single bond.
Single bond.
single bond. समझा? तो नाम में ही पूरा information है. Do you
Yes,
agree?
Yes,
It's a
sir.
normal chain of 8 carbons joined by a single bond. So
Single
I
bond.
apply that same information. There are 8 carbon atoms and they are joined by a single bond.
Single bond.
So what I have drawn is called as the carbon skeleton. क्या बोलते हैं?
Carbon
skeleton.
Skeleton.
Now, the 18 hydrogen would be distributed to each carbon depending on its valency.
Yes.
Yes,
So, if
sir.
you try to satisfy the tetravalency for the first carbon, एक ही bond बना रहा है, तो how many hydrogen you will assign here?
3.
See, carbon is 2 bonds. It will be
2 hydrogen.
TH2,
H2. Then
TH2,
H2.
H2, H2, H2,
H2.
and last.
H3,
H3.
Just naam se we are able to draw the structure. So this will
Yes.
be called as the structural formula.
yes sir,
Now, if you observe, the CH2 are repeated in the chain. How many times?
6 times,
6
Six
times.
times.
So rather than writing 6 times repeatedly, I can just condense and say CH2 in the bracket repeated,
6 times,
and
Times.
then
CH3, CH3,
so this becomes a further condensed form. Call it as condensed structural formula.
yes sir,
So again, I have explored the 3 ways of representing molecular structural and condensed structural.
So
Hmm.
we can add CH3 twice.
No,
carbon,
isn't. This CH3 is attached to second CH2, and this CH3 is attached to the second last CH2. Are they connected to the same carbon?
No, sir.
No. That is the reason you can't condense the CH3 together. So condense का एक rule क्या समझ में आया? Whatever groups are bonded to the same carbon can be
Group.
grouped or condensed together. तो मैं लिख रहा हूं group attached to same carbon. That's important. Can be condensed. समझा?
yes sir,
Yes, sir.
ठीक है? Now there
Sir,
is fourth. हाँ,
in the case of ethane, you cannot write CH3 whole twice.
you can because they're connected to each other, ना? So I can
Yes.
call it as CH3 twice. No issues यहाँ पर. कोई problem नहीं.
Okay. Thank you.
Now there is one more way of representing the structural formula of the alkanes or any organic compound for that matter. I'll just write the N-octane in a zigzag manner. CH3, CH2. 1 time, 2 time, 3 time, 4 time, 5 time, 6 time, and CH3. I've written the same structural formula as I've written upar, but just in a zigzag manner. Samjha?
yes sir,
Yes, sir.
Now, if I just ignore the carbons and hydrogen over here, I can just represent the written compound in the form like this.
yes sir,
मैंने
Yes, sir.
कार्बन और हाइड्रोजन्स को इग्नोर कर दिया, तो एक सिंपल जिगजैग पैटर्न बनाया, माउंटेन टाइप डायग्राम बोल सकते हैं. बराबर? This way of representing the organic compound is called bond line formula. क्या बोलते हैं?
bond line formula,
तो bond line formula shortly मैं बोलूंगा BLF. ठीक है? Out of all the 4 ways, which is the simplest?
Bond line
bond
formula.
line formula,
Of course bond line formula, because यहाँ पर आपको कार्बन हाइड्रोजन लिखना ही नहीं है, but you will understand by just writing a carbon at the intersection of 2 lines. जो भी मैं dot बता रहा हूँ, that dot represents what?
Carbon.
carbon,
If you just draw a C over here, you'll understand the number of hydrogen should be
Three.
3,
3. If I draw a C here, then 2 bonds
2,
दिख रहे हैं, तो 2
2.
वापस,
2.
and last में वापस C will be bonded with.
3 hydrogen.
Three.
मतलब I am able to replicate the same structure by not writing carbon hydrogen.
Yes, sir.
Yes, sir.
So that is called a very simple way of representing organic compound called bond line
PLI.
formula. मतलब the fourth way of representing what I discussed is the bond line formula. ठीक है?
Yes, sir.
Yes.
So,
So going back, how would you draw the bond line formula of ethane?
Sir, two mountain.
to like a mountain.
Two mountain मतलब ऐसा?
No.
No, just one. Two lines.
Two lines. Like this?
Yes.
No.
No, sir. No, sir.
Because this will represent how many
One
carbon,
straight
Paridi?
The
line.
two
One
parallel.
straight line.
No.
Oh, just one line.
One
One
straight
line,
line.
one
Just a line.
line.
Single line indicates two carbon. अब इसको स्लैंट फॉर्म में ड्रॉ करो तो आप बॉन्ड लाइन फॉर्मूला बोल सकते हो, है ना? जस्ट माउंटेन शुड नॉट बी कंप्लीट, बिकॉज अगर माउंटेन कंप्लीट करोगे तो तीन कार्बन, दो माउंटेन बना रहे हो, खाली डॉट्स को देखो कितने कार्बन दिखेंगे इधर,
Five.
समझा?
Five.
देन फॉर इथीन
Two. One straight line.
वन स्ट्रेट लाइन, बट पैरेलल लाइन नहीं करना पड़ेगा.
Parallel lines. Two parallel lines.
मतलब मैथ्स में इक्वल टू साइन हो गया कि नहीं?
Yes, sir.
मैथ्स में ये इक्वल टू है, बट केमिस्ट्री में ये इक्वल टू साइन का मतलब ये इथीन कंपाउंड हो गया. बोलो,
Okay.
समझा?
Yes, sir.
Yes, sir.
Then three parallel lines
Triple.
will be
Triple bond, ethyne.
Ethyne.
ethyne compound. तो ट्रिपल बॉन्ड बाय डिफॉल्ट इथाइन कंपाउंड को भी रिप्रेजेंट करता है इन द बॉन्ड लाइन फॉर्मूला.
Yes, sir.
गॉट
Yes,
इट?
Yes, sir.
Sir,
ओके.
sir,
हाँ,
we don't draw this slanting.
वी कैन, बट ऐसा कोई मैंडेटरी रूल नहीं है. जैसे अभी बॉन्ड लाइन फॉर्मूला is not mandatory to be drawn in a zigzag manner only. I can just draw this in the form of a staircase. If you just tilt this by a 90-degree angle, do you get this? ये देखो, इसको 90 से घुमा, यही मिल रहा है कि नहीं मिल रहा है? बोलो.
Yes, sir.
yes, sir.
पॉइंट क्या है? अगर यहाँ पर if I just draw the dots between the lines, what are they?
Carbons.
Carbon.
1 2 3 4 5 6 7 8. ये भी तो n ऑक्टेन है, जो मैंने ड्रॉ किया है पहले भी n ऑक्टेन था, ये अभी भी n ऑक्टेन है. समझा?
Yes, sir.
Yes, sir.
इनफैक्ट आज के बाद कोई भी शेप आप बना दो, वो एक ऑर्गेनिक कंपाउंड को रिप्रेजेंट करेगा. जैसे इफ आई सिंपली राइट अ डिजिटल एस, है ना, ऐसा लिफ्ट में ये 5 होता है.
Yes, sir.
Yes,
Yes.
sir.
क्या बनाया मैंने? कैन यू टेल मी?
Bond line formula.
ऑफ
Hexane.
सुपर्ब. क्योंकि
Hexane.
6 डॉट्स दिख रहे हैं, हेक्सेन समझ में आता है?
Yes, sir.
यस और नो?
Yes,
Yes,
sir.
sir.
Yes, sir.
अगर मैं एच लेटर लिखूं तो 1 2 3, 1
Again,
2
hexane.
3,
Hexane.
again hexane, but now there is a branch between them. है ना, ये स्ट्रेट लाइन में नहीं है ना 6 के 6 कार्बन.
Yes.
Yes.
its formula would be hexane, but it will be a branch structure. क्या है अभी के लिए?
Isom.
हाँ,
Isomer.
it's an isomer. yes. S और H एक दूसरे के आइसोमर हो गए.
Yes.
Got it?
Yes, sir.
Yes, sir.
अब if I try to enclose the carbon atoms in a cyclic form, then minimum how many carbons I would require to close the chain?
Three.
3.
3. So if I have carbon, carbon, and I join by single bonds, ये बन गया अपना cyclic chain. minimum 3 carbon wala. And if I satisfy
Yes,
the
sir.
valency, how many hydrogen here?
2.
यहाँ पे
Two.
Again 2.
again 2.
Two.
बराबर? And if I
Yes.
just ask you, what will be the bond line formula of this?
A triangle.
Scrap the carbon hydrogen,
A triangle.
just a triangle. तो मैथ्स में इसको ट्राइंगल बोलते हैं, बट आज के बाद केमिस्ट्री में you call it as cyclic compound of 3 carbon, which is named as
Cyclopentane.
cyclo. B carbon is prop, single bond is
Pain.
ane. Cyclo, prop, ane. समझा?
Yes, sir.
So,
ठीक है, तो फर्दर साइक्लिक कंपाउंड में 3 की जगह अगर 4 आता है, तो व्हाट शेप यू विल गेट?
cyclobutane, you'd get a square.
Square would be a cyclobutane, then
Cyclopentane, pentagon.
pentagon would be cyclopentane, and then
Hexagon would be cyclohexane.
Hexane.
cyclohexane, not hexane. Don't call it hexane, it will be cyclohexane. And if I ask you what will be the number of hydrogen at each carbon of this compound?
2.
CS2.
समझा? तो अब कोई भी शेप उठा लो, you will get the structural formula to that. So letter A, can you tell me what does this indicate? Letter A.
Hexane.
Sorry? Yes,
Pentane,
five.
but branched.
So ये वाला पार्ट जो है वो क्या है?
Cyclopropane.
Propane.
हाँ, और उसके ऊपर 2 कार्बन्स का ब्रांच्ड है. If I write a C over here, I'll get CH3, CH3.
Yes.
मतलब 2 मिथाइल का ब्रांच है, इन अ वे वही हुआ ना?
Yes.
Yes, sir.
समझा यहाँ तक?
Yes.
Yes,
sir.
sir.
ठीक है, एनी डाउट?
No, sir.
Okay. So apart from all the representations which I discussed, 4 main representations I discussed, there is one more representation called three-dimensional representation of organic compound. And about 3D, I've already talked with respect to the shape of the molecule. What was the shape when the carbon is single bond?
Or tetrahedral.
Tetrahedral.
Yes. So we know that carbon is sp3 single bonded, and the shape, the three-dimensional, is tetrahedral. Okay. Now tetrahedral refers to how many single bonds to the carbon?
4.
4. So I want to represent the 3D structure onto the two-dimensional region. अब जो स्क्रीन
Yes,
देख
sir.
रहे हो उसमें तो 2 ही डायमेंशन है ना, x एक्सिस और y एक्सिस.
Yes.
बट रियल में अपने पास x, y और
Z.
Z
z रहता है. तो मूवीज जब शूट होती है तो इट्स शॉट इन द थ्री डायमेंशनल रियल वर्ल्ड, राइट?
Yes. sir.
But when
Yes.
we watch them in the theater, we watch it on the screen, which is a two-dimensional.
Yeah.
So how that movie is converted from 3D to 2D?
Project.
हाँ, पीछे से प्रोजेक्ट
Yes, sir.
होके
Project.
वो स्क्रीन पे आता है, राइट?
Yes,
Yes.
sir.
Yes, sir.
मतलब प्रोजेक्टर का काम क्या है?
Convert 3D to 2D.
3D from 2D.
हाँ, two.
प्रोजेक्शन मीन्स कन्वर्ट द 3D टू 2D. आता है समझ में?
2D.
Yes, sir.
Yes, sir.
वही टाइप का एक प्रोजेक्शन हम यूज करने वाले हैं, विच इज कॉल्ड वेज डैश प्रोजेक्शन. वेज डैश projection. What do we do in that? We say that the two bonds which are present in the methane molecule are in the same plane, and they are indicated by normal lines. They are the bonds which are present in the
Same plane.
Same plane. Okay. One of the bond would be coming out of the plane. मतलब जो स्क्रीन दिख रहा है एक बॉन्ड स्क्रीन से बाहर आते हुए दिखेगा. So we say it is a bond coming out of the plane towards the observer. And you are the observer, you are watching the screen. One bond is coming out. And the other bond is going behind the screen, meaning it is going away from the observer.
Away from the.
मतलब चार bonds में से two bonds are in the
Same
Same
plane.
plane.
same plane. One bond which is coming out of the plane is indicated by a dark triangle, which is called as a dark wedge. ये dark wedge जो है, this is the bond coming towards किसकी तरफ?
Towards the observer.
मतलब स्क्रीन के बाहर आ रहा है आपकी तरफ, आपकी आंखों के सामने. ठीक है. और एक बॉन्ड जो पीछे जा रहा है, आपसे दूर जा रहा है, दैट इज द बॉन्ड अवे फ्रॉम द ऑब्जर्वर.
Yes.
Yes, sir.
समझा ये प्रोजेक्शन?
Yes.
Yes.
Sir.
मैंने सिंपली चार बॉन्ड्स का टेट्राहेड्रल रिप्रेजेंटेशन 2D में किया. आप देख रहे हो चारों बॉन्ड अभी आपको 2D में दिख रहे हैं.
Yes, sir.
अरे हाँ कि नहीं? जब आप फोटोज भी क्लिक
Yes,
करते
sir.
हो तो 3D में क्लिक करते हो, बट यू वॉच इट इन द
2D.
2D.
2D. So that is what the projection is all about. So here, the carbons with two hydrogen will be in the same plane. One will be out of the plane. One will be behind the plane. समझा?
Yes, sir.
Yes, sir.
Apart from this 3D representation, there are three molecular models. Molecular models. ठीक है, जिसका information you can refer from the notes on page number 10. The first is called framework model. Framework model में we just show all the bonds to the carbon by the sticks. तो यहाँ पर there will be how many sticks required to represent the bonds?
4.
Can you visualize the 4 sticks in the framework model?
Yes.
Then there is ball and stick model. Ball and stick model में the atoms are represented by balls and the bonds between them is represented by sticks. So we have different atoms indicated by different color. जैसे कार्बन के लिए ब्लैक कलर यूज करते हैं एंड हाइड्रोजन के लिए व्हाइट कलर. सो यहाँ तो अपने पास दो ही एटम है. So I will have one carbon atom which is a black colored ball and 4 hydrogen atom which would be the white colored balls. ठीक है? And these balls would be connected by the sticks which represents the bond
Ball
between the
and
carbon and hydrogen. आ गया समझ में ball and stick model?
Sir, in ball and stick model, sir, it is oxygen then.
Red color.
But sir, how will we show the sticks?
For a double bond?
Yes, sir.
Yeah, that you will have the introduction of the pi bond in detail in chemical bonding, then you will be able to understand. अभी pi bonds आपको नहीं समझ में आएगा. फिलहाल we are just focusing on the single bonds.
Okay.
So carbon is black color, hydrogen is white, and oxygen जब आगे हम discuss करेंगे red color का आएगा. तो ये color codes है just to differentiate the atoms. ठीक है? और तीसरा है space filling model. Space filling model में it just shows the relative size of the atoms with respect to the occupancy of the space. So carbon and hydrogen में which is a bigger atom?
carbon.
Carbon.
Can you see carbon is occupying a greater volume as compared to the smaller hydrogen?
Yes, sir.
Yes, sir.
बस space filling में it just shows the relative space occupied by the atoms, and this space occupancy is decided by one parameter called van der Waals radius. ये क्या होता है आपको पीरियोडिक टेबल में समझेगा. अभी के लिए just remember that the space filling model uses the information of the relative size with respect to a radius called van der Waals radius. समझा?
Yes, sir.
Sir.
Okay. So this completes the initial introduction of the organic compounds with respect to hybridization, bond parameters, and the different ways of representing the organic compound. So there are actually 5 ways which I have discussed. This is the 5th way, right?
Yes, sir.
ठीक है? यहाँ तक कोई doubt?
No, sir.
Okay. So आगे का part is quite simple to understand. It is about the classification of organic compounds. And then I started with the topic of the nomenclature. जो अब तक डिटेल में नहीं स्टार्ट किया है, I've just started with the initial 2 rules. Okay.